All right, here's how you do the problems of lesson 2.03a. And they gave you a list of rational and irrational numbers. Rational numbers, remember, is any number that can be written as a fraction. Like, for example, I'm doing different numbers, okay? So you can try this one on your own, but I chose similar numbers so you have an idea how to do this. So all the numbers that I'm highlighting in yellow, they're rational because they can be written as a fraction, like 29 over 8. That's a fraction. That's why it's called rational. 3.85. Decimals that have an end, they're called rationals. 4 and 3/5. Any mixed number is also called rational. So all of these numbers in yellow are rational numbers that you can write as a fraction. The numbers that I'm going to highlight in green, they are irrational. Okay, square root of 19. If you do this in a calculator, which I'm going to show you soon, you get a long decimal. And those long decimals, when the decimal side has no repetition, is considered an irrational number. And same thing happened with a minus square root of 7. So those are called irrational, the ones that I highlighted in green. And again, irrational means numbers you cannot write as a fraction. And they're asking you to plot. And remember, the word plot means put a point. Okay, so this word plot, let me put this on the top. Plot means put a point. And that's what we're going to do with this list of numbers. We're going to find them on the number line and we're going to put a point where they are located on the number line. So how do you do this? You're going to use the calculator. And what I'm going to do is I'm going to take each of these numbers and I'm going to make them into a decimal with the help of the calculator. So for example, here's my calculator. Let me start with square root of 19. So I'm going to put square root 19. And you can see I got a long decimal. Now here's what I want you to do. What I want you to do is look at any of these numbers that are decimals. In fact, you know what? I'm gonna do something better. I'm gonna put all of these numbers in the calculator. So there's square root of 19. Let me go to another line. Now I'm gonna put the fraction 29 divided by 8. Remember, a fraction is really a division problem. Okay. Let me go to the next number, 3.85. That one, there's nothing to do because it's already as a decimal. The next one, now when you have mixed numbers, the way you're going to put it in the calculator so you get a decimal is a mixed number is the addition of a whole number and a fraction. So 4 and 3/5 means 4 plus the fraction 3/5. And you can see I got the decimal. And finally, the last one, I have 8 subtract square root of 7. And you can see that in the calculator, put all of these numbers in the calculator and you can see I got all decimals. Now what I'm going to do is I'm going to start rounding them so I can find where they go. If you look at the number line, I'm going to try and make this a little bit bigger here. Let's say I click on a dot and you can see that in the number line, okay, the first number is showing you the decimal that will be in. So what I'm going to do, and if you look carefully, some decimals only have one number to the right of the decimal point. Some others have two numbers after the decimal point. Okay, so what I'm going to do is the reason I'm saying that, oops, got bigger here. The reason I'm saying that is because when I start rounding all of these numbers, okay, It's going to be based on the decimal that has more digits in the list. And right now, the decimal that has more digits in the list is 3.85. So I'm going to round all of these numbers. I'm going to make sure that their decimals have 2 digits to the right of the decimal point. So for example, square root of 19 is 4.35 and a long string of digits. Now I want to pick the first 3 digits, and the reason I pick the first 3 digits to the right side of the decimal point, I want to make sure I have 2 digits, like the 3.85. However, I'm going to round, and look who's to the right of the 5 and 8. So I'm going to round 4.35 to 4.36 because the number to the right side of the 5, here's the 5, the number to the right side of the 5 is 8. And when it's 8 or more, you go 1 up to the second place, to the number you want to round. So I'm rounding where the 5 is. I had 2 choices, stay the same or go 1 up. I went up because the number to the right is an 8. Let's go to the next number, 29 over 8. We got 3.625, but again, I'm only going to pick the first 3 digits because I only want 2 digits to the right of the decimal point, and I'm going to round again. So look who's to the right of the 2 or 5. So this will be 3.63. Now 3.85, I don't need to do anything because it already has 2 decimal places, 2 digits to the right of the decimal point. When I go to 4 and 3/5, I don't need to round because I got an exact answer that has less digits, so 4.6. Now, because I want to make sure all the decimal has the same amount of digits to the right side of the decimal point, this 4.6, I'm going to put a 0 at the end because ending zeros don't change the answer when you're working with decimals. So 4.6 is the same thing as 4.60. And when I go to the last one here, again, I'm going to pick the first 3 digits. I want to make sure I have 2 digits to the right side of the decimal point. And I need to round, but look who's to the right of the 5, the last 5 here that I highlighted. Look to the right side, I have a 4. That number's not bigger than 5, so I'm going to keep the 5. So this becomes 5.35. And look, I was able to make each number in the list rational numbers and irrational numbers. I made them into decimal. And once you do this, then you can start plotting them, and that's what I'm going to do now. So for example, 4.36 is 4.3. It's going to be between 4.3 and 4.4. Again, if you put it on the number line, the dot, without clicking, look inside the parentheses, you see the first number is telling you where you are. I'm looking for 4.36, so I'm going to keep moving. Look, 4.35, 4.4. So the closest one is 4.35, even though I got 4.36. So when you are working with irrational numbers, you're going to have to estimate more or less what could be. So I'm going to leave it there. Then I'm going to pick another point, and then I'm going to do 3.63. So 3.63, it should be after 3.6. So here's 3.6. Move to the right. Oops. Look, I found it, 3.63. I will put it right there. Let's do the next one, 3.85. That means it's going to be after the 3.8. Here's 3.8. There's 3.83. I want 3.85, 84, 85. Okay. And the next one is 4.60. 4.60 is the same as 4.6. There it is. And finally, the last one is 5.35. So it's going to be after the 5.3. Here's 5.2, 5.25, 5.3, but I want 5.35. Let me keep moving to the right. There's 5.35. Okay. And that's it. That's all what you have to do let me make this smaller, That's all what you have to do to plot all the numbers in the list when the numbers are rational or irrational. Okay, I hope this helps.